Okay. Then back to this fella. Okay. Okay, great. Okay, so this 1 mark and this 1 mark, please, you should be getting it. Okay, so the variable resistor is set to 2 kilo ohms. Calculate V out at 10 degrees. So again, this is a very simple voltage divider method. So now this fella is 2 kilo ohms. Okay, this is 2 kilo ohms. And we found out from this part that this fella is 20 kilo ohms. Okay. Just out of curiosity, Yixuan, can you tell me, by applying the voltage divider method, what is the V out here? Yixuan, I know this is one of your weaknesses, if you will. Can you calculate what is the V out here? Yixuan, are you there? Yes, Yixuan. I see you with the thumbs up, but I need you to answer me. Hello, hey, Yixuan. Oval is waiting for you, Yixuan. Are you there or not? Did Yixuan leave the room?
He says you're joining on his phone.
Okay.
No.
Out of curiosity, how many of you actually finished trying this paper?
Oh, I actually finished it.
Great.
I set for 2 questions because I don't know how to do.
Okay, okay.
I think it's 1 or 2 questions.
Okay. Great race. Joanne finished it. Okay, Yixuan is back. Well, this is the first time I've had where I asked a student question and he ran out of the room.
No, sir, my mic wouldn't work. Sorry, switch off phone.
Ah, okay, okay.
0.09.
Huh?
0.09.
0.09.
Yeah. R2 over R1 plus R2.
Wait, for some reason, the answer provided is... Okay, so we have Dinanan. Why is Dinanan always going out and coming back in? Okay, so we've got 2V out is 2000 over 22,000 times 12 volts, right? So I've got 2000 divided by 22,000 times 12. You should not get 0.09. You should get 1.09 volts.
I forgot to times 12.
Sorry, I can't hear you.
I forgot to times 12.
You forgot the times 12. Okay, so now you know you got the times 12, yeah? Okay, so the answer is 1.09. volts. Okay? Can? Okay, so next question. What happens to V out as the temperature increases? Okay, so as the temperature increases, what we see is that the resistance drops. Okay, so the resistance here is going to drop. The resistance here is going to drop. All right. So as this resistance drops, the voltage across this resistance also drops. And if the voltage across this thermistor drops, what happens is that the voltage here, the V out will start to increase. Okay, so when the V out increases, basically, that's what happens. All right. So you have to kind of explain it logically and chronologically. So you got to write as temperature increases, the resistance of the thermistor decreases. Okay. Therefore, V out will increase as R thermistor decrease. Can? So I need to be able to see you explain the temperature and thermistor resistance correlation. And because of that, what happens to V out as the correlation occurs? Okay? Question so far? Just checking. No one is raising your hand. We should be good. Okay, so let's move on. So now at 40 degrees Celsius, V out is 6 volts. Okay, V out is 6 volts at 40 degrees Celsius. So over here right now, V out now is 6 volts. Okay, so this is 6 volts. Now, this is 40 degrees. So if this is 40 degrees, let's look at 40 degrees. 40 degrees is over here. I'm going to assume that it is at 5 kilo ohms, okay, over here. If I draw a line here, it's halfway mark, so it is at the 5 kilo ohms. Yeah, so this fella is now 5 kilo ohms. And we need to find out what is the value of the variable resistor now. Okay, so this one is part C. This is part C. To solve for part E, maybe I'll change to a different color. So to solve for part E, I want to find this one. So I'm going to employ the very same method, right? The voltage divider method. So V equals to, now it's the unknown. Okay, it's the unknown over 5,000 plus the unknown multiplied by 12 volts. And here, they already told me what the voltage out is. It's 6. So I can replace this with 6 volts. Okay, so this is the method, and the unknown, once you press your calculator, should give you 5,000 ohms. Anyone unsure of the method, what I was saying, how I derived the equation or anything, please raise your hand. Okay, great. So the answer here is 5,000 ohms. Okay, let's go on to question 4 now. Okay. Okay, name the two signals here. This is your sinusoidal. And this is your rectangular. Ken? Okay, so then next question is they ask whether it's the AC or a DC. So this fella, let's get Shreyans. Can you unmute yourself and say whether this is AC or DC?
Graph 1 is AC.
Yes, awesome, thank you. And what's graph 2? Ruhan, what's graph 2? This fella, AC or DC?
DC.
Excellent. Okay, so both these graphs, because they follow a fixed period, right? So both of them are periodic. Okay. Okay, Ken? All right, so now we are just going to concentrate on graph 1. We're just going to concentrate on graph 1, peak voltage. Okay, so the peak voltage is from the rest position all the way to the max. What is the voltage? You should get 12 volts. Peak to peak, VPP, it is from the peak all the way to the trough. Okay, if this is 12, this will be 12, and therefore VPP will be 24 volts. Okay, next, period. Period is the time taken, part 3, period is the time taken for one complete wave. So this is one complete wave over here. So this is the period over here, T. Unfortunately, they did not give me the value over here, right? They didn't give me the value over here. Instead, they gave me this value, 1.5 seconds over here. So not to worry, I know this is one wave and this is 1.5 wave, right? So if I know the time for 1.5 waves, I'll definitely be able to find what's the time for one complete wave. Okay. So 1.5 waves, 1.5 waves is equivalent to 1.5 seconds. Therefore, the period, which is one wave, is 1 second. Okay. And frequency formula is 1 over t, therefore it's 1 over 1, and you have 1 hertz. Okay, so far, question 1 to 4, I have to say that so far, all the marks should be very easy to get. And based on the previous year's O-level papers, right, it is something like that as well. The section A, which is worth 40 marks, usually these 40 marks, I would say as high as 35 to 36 marks is very, very easy to get, okay? So long as you study, you know your stuff, the section A 40 marks, you should score very high, okay? Oh, there's one more, part D. Give an example of a periodic or non-periodic signal. This one is very open-ended. So there are many, many questions. Periodic signal, you can talk about a clock signal, okay, a digital clock signal. You can talk about even real-world examples like a metronome. Okay, Ken? So there are many, many other examples. It's not just limited to 2. A non-periodic signal, I think the most common is what I'm doing now. Okay, just someone talking. Okay, it's not periodic. I do not talk like a robot. Okay, or even as open-ended, if you want to put applause, a group of people clapping, giving applause. Okay, so you just need one of each, and I need to be able to see your answers in order to say whether it will be accepted or not. So does anyone have any questions on part D?
So, but didn't they ask for a signal?
Yes. So I'm going to assume that this talking and this applause is going to be fed into a transducer. So what's your answer, Shreyans?
Oh no, sorry, I didn't attempt it. I got confused, that's why.
Okay.
Okay. Got it, thank you.
Any other questions? I'll take that as everyone is fine. Now we'll go on to question 5. Okay, so again, these 3 marks, you should be able to get it because they're just testing you on the prefix. Okay, they're just testing you on the prefix, whether you know what micro is, nano, pico, micro. Okay, so all this, they're all capacitors, capacitance values. You just need to be able to know what the prefixes are. Okay, so what I would do is that I would just put them in terms of no prefix. What I mean by that is that I'm going to leave this as 100 farad, and this fella, I have to know that micro is 10 to the power of -6. Okay, so this is 1, 2, 3, 4, 5, 6. So this is 0.00047 farad. Okay, this one I'll leave it as 1 farad. This one is nano, so it's 1, 2, 3. Okay, so this is 0.12345 right? 1, 1, 2, 3. 1, 2, 3, 4, 5, 6. Yes. 1, 2, 3, 4, 5, 6. Okay. And this one is pico, so it's going to be an even longer one. 1, 2, 3, 4. Tell you, I'm just going to write this to 10 to the power of 12. Okay. And this one is 1. All right. Okay. So 1, 2, 3. So this is 3.2 nanofarad. Okay, so this one is already smaller than this one. So we'll have a comparison. Okay. So now I've got all my values in order. I'm going to arrange them in ascending order. So the smallest one will be here. So the smallest is the pico, right? Because already if I convert it to nano, it's already smaller than 100 nano. So my smallest would be 3200 picofarad. Okay? Okay, so now let's ask James. James, what do you think is the next biggest one, James? James, are you there? Hello, James. Okay, James WhatsApp me. He says 1 microfarad. No, the next biggest one is not 1 microfarad. Nano. Okay, this fella is smaller than this fella. Okay, this fella is smaller than this fella. Okay, so if this is bigger, that means the next biggest one should be the 100 nanofarad. Okay. Okay, next. After this fella, then is this fella, 1 microfarad. Right? So then after you rearrange it, the next biggest one would be this fella, 470 microfarad. Finally, 1 farad. And the biggest one would be 100 farad. Okay. Any questions on this? No? Okay. So next, how do I arrange any of these two capacitors to form 101 farad? So it's quite a very easy question because there's 1 farad and there's 100 farad. So all I need to do is just be able to add 1 farad to 100 farad, and this gives me 101 farad. Yeah. So in order to just simply add them, these two capacitors must be placed in parallel. Okay, so remember, capacitors are the opposite of resistance. If you just want to add them, they must be added in parallel. So all you need to do, okay, so I don't have a ruler, a digital ruler with me right now, but all of you must draw this in pencil and with ruler. Okay, so I must have 1, 2 in parallel. Okay, CJ just entered. He's pretty late. Welcome, CJ. Like so. And please remember to label them. Okay, so this is 1 farad. This is 100 farad. Okay. Okay. Next. What are capacitors used for? So capacitors used for a lot of things. You can write for time delays. Okay. You can say for timing circuits. Okay, something to do with time. You can say it is used to smooth out a full bridge AC to DC output signal. Okay, you remember after the full wave rectifier, the AC to DC, I taught you that you can put a capacitor there in order to smoothen it out a little bit. And so they just needed two, but there is also one more third application that I taught you in your BJTs, in the chapter on BJTs. The capacitors are also used as coupling capacitors. Okay. James, do you want to? Yes.
Sorry, what about RC circuits?
RC circuits. Yes, you can write time delays, timing circuits in RC circuits if you want to be more specific. But if you just wrote in RC circuits, it is also accepted.
Okay, thank you.
Okay, so that is the end of section A. Like I said, section A, the 40 marks, you should be able to get the 40 marks quite easily. If not 40 marks, maybe at least 35 marks. So that's your target. Okay, now we go on to section B. So section B is where a lot of the application questions appear. So you not only have to know your content, you have to know how it is applied. So this one, to study it, you just need to be able to understand all the components, and you must know how the components work. So usually for section B, this is where the testing of your chapter 14 IC chips, your digital gates, all this should appear in section B. Okay, so with that in mind, let's dive in section B. Okay, so greenhouse, all right, temperature control, master switch, and it monitors the temperature using a transducer. There's also a light detector to sense day and night. The heater switches on when the temperature is too low or when there's no light, okay, or when there's no light. The window is closed in the beginning and the window opens, the temperature is too high, okay? Window closes when the temperature is too low. Okay, so, and these are the signals corresponding to these, right? Okay, so using these, arrange them in the input, process, or output subsystem. Okay, so master switch is already done. Let's look at a temperature sensor. Maybe we can have Sharaf, temperature sensor. Which box do you think we should put it in?
Input.
Very good. So let's write temperature sensor, and this is capital T. So we are done with this. Heater. Now let's ask CJ. CJ, where do you think the heater should be? In the
Output.
input, output. Very good. So this is the heater. So we are done with this. Light sensor. Who have I not called out for today? Let's ask Alistair. Alistair, what about the light sensor? Sorry, I couldn't hear you, Alistair.
Yeah, asking where to put it, right?
Yeah.
Input.
Input. Awesome.
Yeah.
So this is light sensor. Okay. And lastly, the window. Okay. Whether you open or close the window, that is your output. Okay. So far so good. Okay. Okay. So now they want me to fill up the truth table. First row has been done for you, the 3 inputs and the output. Okay, so the inputs you don't have to think, right? Because they are all fixed. So it's always, it's not sometimes, it is always 0, 0, 0, 0, 1, 1, 1, 1. Okay, so that's always the first line. Our second input was temperature sensor, T. So let's go with T. So the second one is always 0, 0, 1, 1, 0, 0, 1, 1. Okay. And the third one was the light sensor, L. So the third row, sorry, the third column is always 0, 1, 0, 1, 0, 1, 0, 1. Okay. The output, we had 2 outputs, was window and the heater. Okay. So now we got to look at these conditions here. Okay. The heater switches on when the temperature is too low or when there's no light detected, when it is too low. So temperature is too low when T is 0 or when there's no light. L is 0 as well. Okay, so I'm looking for T is 0, L is 0, or it doesn't have to be both and, it's just either or. Okay, so the heater. So let's go back down to the heater. So the heater, L, the light, wait, what did I say? The L0 and T0. Okay, so the L0 oops, where's the highlighter not working anymore? Okay, never mind. We put a yellow. Okay, so L0. So whenever there's a L0 or a T0, okay. Whenever there's a L0 or a T0, what happens is that the heater switches on. Okay, so the heater switches on means it is H1. Okay. So the H1 occurs here, the H1 occurs here, H1 occurs here, 1, 1, 1. Okay. Okay, so far? Okay, next, the window. Now we are going to look at the window. Okay, so the window opens when the temperature is too high. Okay, so the window open one when the temperature is too high, when T is 1. Okay, when T is 1, W is 1. So when T is 1, W is 1. Okay. Okay, but then they never say anything about the master switch, yeah? So I suppose it only works when the master switch is on. So all this will only work if the master switch is on. So I got to relook at my table again. So the master switch is off here. And I'm going to assume that none of these sensors will work when the master switch is off. So therefore, I have to revise my answers for this. Because all of this, the master switch is off, no sensors will work, and therefore none of this will work because the sensors are not working. Yeah. And therefore, I end up with the truth table like this. Okay. Any questions on how I populated the truth table? I'll take that as a no. Okay, so now they want me to write the Boolean expression for H. Okay, for H. So I've got 1, 2, 3 that gives me a 1. So how do I get 1? I need to have M. I need to have T complement and T complement and L complement. Okay. Or the second one is M and T complement and L. Okay. Or there's one more here. There's one more here. Or M and T and L complement. All right. So now the output W, I've got this two. So I've got M and T and L complement. Or I also can get W as a high through this combination of M and T and L. Okay. Any question? Let's see. Now must also check my WhatsApp. Okay, no questions from the WhatsApp. I don't see anyone raising hands. Okay, then let's go on to K-max. All right. So now for output H, only for this fella, for output H. They want me to populate and simplify this Boolean expression. Okay, so first of all, let's say this is M, okay, and this is TL, okay, TL. Usually we always put the 4 zeros followed by 4 ones over here. Okay, so this M, and this 2 is your TL. So always remember, this is your 0, 1. This is your 0, 0, 0, 1, and this is special. It is 1, 1 first before it is 1, 0. Okay, you must always follow this pattern. So now we can populate it. Use green. Green seems like a nice color. Okay, so for H, these are my 3, right? 1, 0, 0. So it is 1, 0, 0. Okay, this is 1, 0, 0. Gives me a 1. So therefore, I'm looking for 1, 0, 0. So this is 1, 0, 0. Next, it is 1, 0, 1. So 1, 0, 1 is a 1 here. And lastly, it is a 1, 1, 0. So 1, 1, 0 is here. Okay. So these are my 3 ones. And I'm going to populate the rest of my K-maps with 0, 0, 0, 0, 0. So now we have to group them. Okay, so the first group is pretty obvious. I'm going to choose another color, pink. They say pink is the new black. Okay, so first group is pretty obvious. This is your first group here. Okay, let me ask Ashwin. Ashwin, I see you here, Ashwin. Ashwin, tell me whether I'm right or wrong. My second group would just be a very simple one here. Would I be correct?
Yeah.
What if I told you that if I do this, it's not that I'm going to be 100% wrong. It's just that there is a better way to group.
Oh
this
yeah,
one
with the other twos.
with the others. Is it?
Yeah, yeah.
So do I group like that?
Yeah.
Do I do this?
Yeah.
What if I told you I'm still wrong?
Oh, okay. I don't know.
Okay, not sure. Let's ask Kiran. Kiran, what did I do wrong when I grouped this with the other two?
You group in 3. You only can group in 1, 2s, and 4s.
Excellent. So very important to learn that you only group in 1s, 2s, or 4s. You can't group in 3s. Okay, Ashwin, got it?
Yeah.
Awesome. Okay, so now let's group it in 2. So now the correct grouping is this fella and this fella. Okay, so now I'm going to settle the pink one first. Okay, so I'm looking for the common ones that do not change, right? From here to here, the M does not change, right? It's still 1, 1. So the M does not change. So I do want a M, okay? Then I look at my T. My T is 0, 0. From here to here, right? I'm moving from here to here. From here to here, 0, 0. So T does not change as well. So that's what I also want. But since T is 0, 0, I want the complement. So T complement. Okay. So I've settled the pink one. Why is it not pink? Where's my pink?
Bottom left.
Hey, thank you. M and T complement. Okay, so this is the pink. But I also have one more group. So I can have this or, okay, or now I look at my orange one. Okay, so same thing. If I'm moving from here to here, the M does not change. So I still want M. Okay, and T changes. See, T changes from 1 to 0. So I don't want T. L stays at 0. So I do want L. So, but since L is a 0, 0, I want a complement of L. Okay? Are we good? So solving K-maps. Any question? I'll take that as a no. No raised hands. So now they also want to simplify for W. Okay, so those of you who have not done it, I want you to do it right now. Okay, don't look up at the screen. I want you to do it right now. Those of you who have done it, I'm going to populate the K-maps and I want you to check your answer. Okay, but those of you who have not done it, please don't just copy. I want you to try it yourself right now. Okay.
So
Yes.
yeah, when we group, right, it's ones, twos, and four, right?
You only group in 1, 2s, and 4s. Yes, that's correct. Once you're done, you can look up, check your answer on the screen, but only if you're done. Okay, so I'm going to give you about another 1 more minute. Okay. Anyone has any question? Are we good? I don't see hands raised. I see a thumbs up from Joanne. Thank you. Okay, let's move on to actually drawing out the circuit using the various gates. Yeah. So I'm going to write down the H here, the H output, so I don't have to keep going up and down. So the H is M and T complement or M and L complement. Okay, so now they want me to draw out the logic circuit for these two. So there's two outputs, W and H. So I'm going to tackle the easier one, okay, the W output, because it's just an AND gate. It's just a very simple AND gate. So let's tackle the W. Okay, so I'm going to have a AND gate maybe here. Again, I don't have a ruler, but you guys need to have a ruler and draw this with a pencil. Okay, so it's just M and T. So this is the M and T, like so. Okay, so I've settled my W. This is done. Okay, it's just M and T gives me W. So this is done. Next, I have to settle my H, which is a slightly more complicated, but it's easy, doable. So the first one is an AND gate. I need to have basically another 2 more AND gates because it's M and T complement, M and L complement. Okay, so I need 2 more AND gates. So what I'm going to do is I'm going to draw 1 more AND gate here, and I'm going to draw 1 more AND gate here. Okay, now this 2 is going to be odd together. They're going to be odd together. Maybe I didn't leave enough space. Odd together here. Okay. Let me shift this to the left slightly. Okay. This will be AND gates, like so. Okay. So this is N, and these 2 N's are going to be odd. Okay, so this is N, they're going to be odd. So let's settle the first N input, M and T complement. So I need M. So very simple. I'm going to draw a node here. This is going to be here. So this is my M. T complement though. So I need a NOT gate here, like this. Okay, so this is M and T complement over here. Okay, so this is your M and T complement. Any questions so far? Yes, then Anand, I see you raise your hand.
I get this part, but I just don't know how to. What do we follow to make the key maps? That one always a problem.
Wait, sorry, I don't understand. Your problem is making a what?
The key maps. What
The
do we
K
follow?
map.
Yeah. No, yeah.
Oh, this one.
Yeah.
Okay. This one, do you understand? For this particular one.
I know how to write it down, but I don't know what to follow.
So you know how to write down these. Do you know
Yeah.
how to populate it with the ones and the zeros inside?
No.
You don't know. Okay, so one more time, I jump back one more time. So I'm looking at W. Okay, I'm looking at W. W is over here. Okay, this is W. I'm just looking over here. Okay, now for W, the output that is 1. The output that is 1 is only this and this. The rest are all zeros. Okay, So what I always like to do is that I only like to populate the ones first because everything else will be 0. So what I mean by that is, in order for W to get a 1, in order for 1 to happen, 3 things must happen. M is a 1, T is a 1, L is a 0. So when M is a 1, T is a 1, L is a 0, then I get my output of 1 for W.
Yeah, I think now I get it
Okay.
now.
Okay. So remember, M1, T1, L0.
Just following the
Yeah. So
thing.
M1, so it's this row, T1, and L0. So it's 1, 1, 0. So this row and this column intersect. That's why I have the 1 here.
Hmm.
Okay. Can I? Okay, so using that break, the rest of you should have tried the next part. We have finished with M and T complement. Now it's M and L complement. So M, you can actually draw out one node here. So this is your M and L complement. So I'm gonna have another NOT gate, and this goes for my L. Okay, so this is my M and L complement. This is my M and T. Okay, so this is my completed circuit diagram. Any questions? Any issues, any questions on? Let's see, I don't see a raised hand. Okay, good. Okay, so now they want me to simplify using universal gates. Okay. Using NAND only, yeah, and simplify your circuit to use as few NAND gates as possible. Okay, so just a quick revision, universal gates. Okay, so the N, when I want to use universal gates, this is equivalent to this. Like this. Okay. If I have a NOT, okay, a NOT. Okay. And if I have a OR,
Who is so loud?
okay. So we are going to use these universal gates to replace all of this. Ken? Any question? Do you all want to try it first? I think we got time to let you try it for 3 minutes. And then I will show you the answer and we will stop here for today. Okay, so those of you who have not tried it, please try it now while I write out the answer. Okay. This is my knot. I got to bring down one more M. This is my N. Okay. This is my H. Okay. So this is all my universal gates, but of course we know that we can further simplify it. So this is a knot, this is a knot. So the knot of a knot is going to give me the original. So this and this, they are redundant gates. Same thing here. This is a knot, this is a knot. So like I said, the knot of a knot will give me the original signal in any way. Yeah. So I can cancel these two. So I'm going to erase it here. Okay, I'm going to erase it here and simplify it on the spot. Okay. So since these two are redundant, I can take it away. They cancel each other out. Okay, so I can actually replace it with just one line here, like so. So this will be my final simplified circuit diagram. Okay. Okay, the time now is 10:55. I don't want to start the next question because then it won't be here or there. So I'm going to stop here for today. Are there any questions that you might have for me today? I don't see any raised hands. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait, who do I have?
Sir, Lucas not here.
Yes, where is Lucas?
Okay.
He is in the WhatsApp chat group, right? Hopefully we'll see him later during the coursework. So don't worry, even if you have any questions later on about this paper or the next 3 questions, you can ask me later on. But I will see you guys later at 2 o'clock. And
Yes,
I was
sir.
reading in the WhatsApp chat whether you can buy food to eat. Yes, you can. Just space yourselves out outside the classroom. Sit down on the floor. You can sit down on the stairs at the stairwell. You can have your food, and then we'll start between 2 to 2:30 whenever you are ready. Okay, I'll open up the room at 2 o'clock. Okay.
So,
All right. Great. So
yes.
I will see you guys later.
So,
Yes.
for me, right, because I got DNT in electronics, right? When do I come
Yes.
for electronics coursework? What time?
Okay.
Because I really don't know.
Who's your D&T teacher?
Mr. Kwok.
Mr. Kwok.
Yeah.
Okay. So I tell you what, later on, you go for your D&T first. I will communicate with Mr. Kwok to see what time you can come up.
Okay.
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 All right. Okay. So in that case, I will see all of you later on at 2 o'clock.
Okay.
Okay. See you guys.
So,
Yes. Yes.
so I just bring my laptop later and I ask you for help for the baptism.
Yes.
Okay.
Sir, sorry. Just want to ask,
Yes.
have you ordered the components?
I have ordered the components. Element 14 said that it has shipped out, but I don't know when I will be getting it.
Okay. Okay. Got it, thank you.
Okay, any other questions?
Is it computers?
Wow, that's a good question, man. I'm not sure. I haven't been up to the room in 2 weeks.
You can let us.
Okay,
Because-
we'll check. We'll check later.
I have to just start. Yeah, bye.
Okay, I'll see you later. Bye.
Bye, sir.